Okay, so this is the lesson on Core 2 trigonometry. This is just going to be a revision lesson, so mainly going to be tackling past paper questions, just going through some of the techniques. Right, so we've got sine theta, cosine theta, and tan theta. You guys do need to know how to sketch these. So just looking at sine theta, max value is 1, min value is -1. We have a peak at 90 degrees and a minimum at 270 degrees, and we cross the axis at 180. Cosine is completely symmetrical about the about the y-axis. Again, maximum 1, minimum -1. But we cross at 90, the minimum is at 180, cross at 270, and then have a maximum again at 360. Sine is the one that's a little bit different, a little bit hard to remember. It actually goes on forever, sine. So we've got these asymptotes at 90 degrees and at 270, and the tan will never take a value. It won't take a value at 90 or at 270. So we'll approach it, but we never ever cross that asymptote. So with tan, best way to draw it, always put the asymptotes in first. If you're not sure where they are, you can get a calculator out. You just do tan of 90, 180, 270, 360. You get two of those as giving you a math error. That tells you there's an asymptote, and then you can sketch what happens in between. With sketches in Core 2 trig, first of all you can use them to solve problems, same as we'd use a cast diagram for. But you also need to know these for your transformations. So they can ask you to sketch sine, cos, and tan, stretched and translated and reflected, same as they can in Core 1 coordinate geometry transformations. So just make sure you're comfortable with your transformations and what they'll do to these curves. Okay, trig identities then. You guys only need to know two of these for AS, and you need to know a whole lot more next year, but we're only going to concentrate on two you guys need to know. First of all, you've got sine squared theta plus cos squared theta equals 1. There you go. If you want the proof for that, it is actually in your lecture notes, so have a look back through that, or it's in the textbook, page 155. Second identity you guys need to know is that tan theta equals sine theta over cosine theta. So if they ask you anything to do with simplifying or solving trig identities, you're going to be using one of these two formulae. You just need to work out which. Generally, if you can see a squared sign, it's going to be the first one. If you just have a single trig function, say you just got tan, you can then rewrite that as sine over cosine. But we'll look at some examples of where that comes in later on. Okay, so a couple past over questions to work through and see how you guys get on. So first of all, okay, so find all values of theta in the interval 0 to theta to 360. First of all, for tan, 2 theta is 0.4. And second of all, 2 sine theta tan theta equals 3. Okay, so the first one, tan 2 theta equals 0.4. The first step to solving any of these problems is to work out what your new intervals are. So, find new intervals is our first step. In the question, they're asking for values of theta in the interval theta is between 0 and 360. If you look at this, our angle is no longer theta. The angle we're talking about is 2 theta. If you're unsure about the angle, it's the bit that your trig function is operating on. So the bit you're operating on goes inside the function. So our angle is now 2 theta, which means our limits, we have to multiply our original limits by 2 to get them. So 0 times 2 is still going to give us 0. So we're going to get 0 to 2 theta to 720 degrees. Okay, now we can just solve the problem like a normal trig identity kind of question, and then at the end solve for what theta is. So I'll do this using cast diagram and also looking at our diagram as well, in case you guys are not too keen on the cast diagram method. Before we do either of that, we need to work out what our primary value is. So to do that, we'll do tan inverse tan of 0.4. So if we calculate our primary angle, our inverse tan 0.4, and we get 21.8 degrees. So that's the angle we're going to be using both for a cast diagram or for sketching on our tan curve. Okay, so first of all, cast diagram. You guys should again all be pretty confident with these by now. If not, check through your notes. So we've got a diagram there. A, S, T, C there. And our primary angle is going to be 21.8 degrees. So first of all, you need to ask yourself, is tan positive or negative? So we look at our value there, 0.4, that is positive. So we're going to be in the A or the T regions of our cast diagram. So I put the angle in, there and there, always measuring from the x-axis, 21.8 and 21.8 there, and we're looking for angles between 0 and 360. So our first value is going to be 21.8, our second value is going to be 180 plus 21.8, giving us 201.8. And let's keep looking, do we get any more values? Well, we probably do, because our limits are going up to 720. So we've got to go all the way around our cast diagram again. So we've got 21.8, 201.8, keep going round, and we're going to get 360 plus 21.8, giving us 381.8 degrees. And we go around the cast diagram one more time and get to there, which will give us 540 plus 21.8, which will be 561.8. So there we go. Those are our 4 angles for 2 theta between the limits 0 and 720. To properly answer the question, though, we have to then give our answers in terms of theta. So we have to divide each of these ones by 2 to find out what theta is. So our theta values are going to be as follows: 10.9, 100.9, 190.9, and 280.9. So those are for values. At the end, always worthwhile just checking, are those for values in our original limits, because we changed back to theta. Yes, 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 and yes. Brilliant. Okay, question 2 then. A little bit trickier, because we're going to have to use an identity first before we can go to solving these. So question 2, we're going to need to use one of our trig identities first. So let's go back up to our trig identities R. So these two, we've got sine squared plus cos squared is 1, and tan theta equals sine theta over cos theta. The only one we can really use that's appropriate is going to be tan theta equals sine of cos, because if you notice, none of these trig identities are squared, so there's a little clue there. So let's rewrite this using that trig identity. So I've just put sine theta over cos theta in there instead of tan theta, because they're the same. Okay, so if we multiply this out, we will end up with 2 sine squared theta over cos theta equals 3. Then we can try and rearrange this. So 2 sine squared theta equals 3 cos theta. Okay, so we still can't really solve this one. Let's go back to our trig identities again. So sine squared theta plus cos squared theta equals 1. So now we have a sine squared theta term. We can use that second identity. So because of the second identity, we can say that sine squared theta is going to be 1 minus cos squared theta. We can put that in now. Okay, so now this is starting to begin to look like a quadratic, which is brilliant. So let's rearrange this one and solve our quadratic. So expanding our brackets and rearrange, and then we're left with a quadratic equation. So we can factorise this one, and we'll get the following. And then the solutions to that will give us cos theta as a half, or cos theta equals minus 2. There we go. Okay, so if we go back up to look at our cosine curve, you can see straight away that minus 2 isn't going to happen. Minus 1's there, so minus 2 is down here. Cosine is never equal to minus 2. So that solution ain't going to happen. Cos theta as a half, however, will happen. So if you look there, we've got half there, there'll be one value there, and another value there. So we're probably going to be looking at 2 values between 0 and 360 degrees. So if we use cast diagram, or we can use our sketch there to solve this one. So inverse cos of a half will give us 60 degrees. So our primary value of 60 degrees, and we can use this on our cast diagram as well. Okay, so let's use the other method to solve this one. So we've got theta is 60 degrees. So if we look at our sketch of cosine theta, we've got angle there, 60 degrees. We're going to have another one over there. So the easiest way to work this out, we'll say that this distance here is 60, and that's from our maximum point. If you look at the other maximum point at 360 and go 60 backwards, that will give us our other value. So 60 this way, 60 this way, we can do 360 minus 60, which will give us our theta value equals 300. And that result will agree with the cast diagram, so we'll do that very quickly. So we get 60 degrees all the way around and 300. So theta equals 60 and theta is 300. Okay, so that was a quadratic example of a trig function question. We're going to look at the other outcome, which is when you need to factorise. And this is very common place to make mistakes. So I'll get you guys to solve this one, then we'll go through the solution in a second. Okay, so there's a question. Solve for x is between minus pi and less than pi. 2 tan x minus 3 sin x equals 0. So I'll pause the tape now. I'll give you guys hints in a few seconds time, and then we'll go through the solution. Okay, so hints and tips, things to look out for. First thing, obviously, this has to be in radians, so make sure your answer's in radians. You've got pi there, so minus 180 degrees and less than 180 degrees, but we need to be thinking about this in terms of radians. Second of all, we've got two trig functions there, so our first step is probably going to be to simplify this and change our tan around to try and make this a bit easier to solve. So if I go through the solution with you guys, step 1 is going to be use our trig identity to write tan x as sin x over cos x, as so. Then we can multiply through by cosine x. And this is the point where students quite often make mistakes. Okay, so at this stage, some of you will have tried to divide through every term by sin x, and some of you will have factorised. If you divided through everything by sin x, and I'll show you the wrong example here very quickly, so this is in red because it's wrong. If you did do that, you would get two of the solutions correct, but you'd lose your two sin x solutions. So we can't do that. Never divide by a trig function to get rid of it, or you lose half of your solutions. Just make a note of that. Okay, so what we do need to do is to factorise. So each of our terms is a common factor of sin x. Let's pull that one out as a factor and see what we get left. There we go, so sin x multiplied by 2 minus 3 cos x equals 0. So either the sin x term or the bits in the brackets have to equal 0. So our first solution is sin x equals 0, and our second solution, there we go, cos x equals 2/3. So you would have got that solution anyway if you had done your method wrong, but you would have lost this sin x equals 0 solution. So always be careful, make sure you factorise first before you try dividing anything out. Okay, so we wanted to solve this between minus pi and pi, so we'll have a look at a cast diagram for this one. We'll go through the sin x equals 0 first. Okay, so first solution, sin x equals 0. I brought back up our sketch of sin x. If we put this in terms of radians instead of degrees quickly, we can see what sine does between our limits. So we want to find any solutions where sin x equals 0. So let's have a look at it. We're going to have 1 there. Sine's going to come down here. I'll add the sketch on. So we can see that we're going to get one solution at 0, one solution at minus pi, one solution at pi. So this is where this question can be pretty tricky. You need to check your inequality signs. We want x less than pi or greater than or equal to minus pi. So our two solutions are only going to be x equals 0 here and x equals minus pi there, because this solution is not included in our limits. Right, brilliant. So we've got two of our solutions. Let's go over and solve for the other one. So cosine x equals 2 over 3. We'll use a combination of cast diagrams and our cosine curve for this one. So first step is to find our primary angle, so inverse cos of 2/3, and we get 0.84 radians. Remember, the limit's in radians, so our answer needs to be in radians as well. Okay, so on our cast diagram, 0.84. We need to put our cast diagrams in terms of radians as well. And 0.84 is less than pi by 2, so our angle is going to be somewhere in this quadrant. We're dealing with cosine, so it's going to be those two quadrants, and we've got 0.84, so let's label that as well. Okay, so looking at our diagram, we're looking between 0 to pi and then 0 to minus pi, so it's going to be this bit here, stop there, this bit here, stop there. It's quite clear that our two solutions are going to be theta equals 0.84 and theta equals minus 0.84. Okay, so just have a look back at our sketch and just show the similarities between the cast diagram and the cosine curve. So we're looking between pi and minus pi, and we want values where are equal to 0.84. So 0.84 is about there. So it's going to be that value there and that value there. That one gave us 0.84, so that one there is also going to be minus 0.84. Okay, so our four solutions to that, we get 0, minus pi, 0.84, and minus 0.84. So when you get one of these trig identities questions, there are only two ways they can ask it. First of all is one where you have to factorise, like we just did, and second of all is one where you have to solve a quadratic, like we did earlier on. Okay, that's it for trig then, guys. I'll leave you with one more question, and I'll put the answers up as well, so you can work through this one on your own time. So there you go.